PMP, project management. I'm also PMP, certified PMP, project management professional. So I have experience in all kind of project management methodologies, including Agile. And I have mentored more than 50 Six Sigma Green Belt projects during last 5 years working on this profile. And I do run the Six Sigma Green Belt and Black Belt classes, 5 days and 140 hours for Black Belt and 40 hours class for Six Sigma Green Belt. This is a brief about me. So today I'm going to touch upon interesting topic, that is Six Sigma Green Belt. And basically last time I had touched upon the topic of Toyota manufacturing system, that is called lean in layman's language. Today we will talk about the Six Sigma Green Belt and Six Sigma DMAIC methodology that will basically facilitate you to understand that what is the difference between these two methodologies. If you are not attending my last class, probably AgileWaters team would have recording of it. You can have a look at that. So let me start with that. So the day one of the Six Sigma Green Belt class basically start with a welcome message, some of the team activities. We divide the group into 4 or 5 groups of 4 to 5 people each other. Handshaking happens on the day one. So before going into the details of Six Sigma methodologies, let me walk you through the different methodologies for the continuous improvement, what is their background, and how to select the right methodology. So basically, the right methodology is selected based on the 2 criteria. Number 1, the difficulty or complexity of the problem statement you are trying to solve, and then the impact of it. So what happens that in your processes, in your operations, you will often come across the cases where you would have a simple problem statement and you would have upfront solution available for them. For example, a simple automation, developing a sort of macro, writing a script. These kind of projects where difficulty level is pretty low, but the impact is pretty low as well. They are called just do it or workout process. This is a simple process improvement where you just sit with your team members, couple of people, you decide to do something. And the most importantly, the solution to the problem is upfront known. So you really don't need to do any statistical testing or value stream mapping or any sort of analysis based on data. On the other hand, there are some projects where the difficulty level is pretty high, but there is no much impact on the company's ROI. ROI is return on investment. There is no significant impact on the processes, but they are kind of a customer experience improvement processes, or they are some kind of additional value to the customer. These kind of projects you will be just having enabling projects them. For example, when you are doing some bigger projects, you may take up this activity as an add-on, but generally we do not do significant projects on them and we do not invest time on that. The important part is the low difficulty or complexity but high impact things. For example, automating a process at all, eliminating the waste from your processes. And I have touched that one in details during my last interaction with you guys. These are the lean or Toyota production system projects in the industry. These are done through the value stream mapping. The value stream mapping is very important tool in lean. Basically, you divide the complete process in small blocks. You do the time and motion study for each of the block. You identify the 7 kind of waste. So a typical lean class, when you want to learn the Toyota production system, is a 3-day class. That is a 24 hours of learning, through which you will get the certification as a lean facilitator, and you can actually conduct the lean projects across the industries. The good thing about this is, although the lean started as a manufacturing improvement program, today I have very well implemented it across the service industries, and the company like TCS, Infosys, Microsoft are using the lean methodology to improve their processes. The good thing about the lean is the investment is low and the ROI is high. In lean, you identify the process gap through value stream mapping. There is no much data mining involved here. There is no statistics involved. and you find the real-time solutions to the problem. One of the important concept of lean is Gamba, go and see. That is we covered during the last class. So it's a 3-day class basically. Now it comes the interesting part, that is Six Sigma improvement projects. When we talk about the background of the Six Sigma, it started from the General Motors. It was automobile company that wanted to improve their processes for the long term through the data investigation and fixing the root cause of the problem rather than patching it up from the top like a band-aid. So basically, Six Sigma improvement projects are run through DMAIC methodology. We are going to talk about it in much details. So Six Sigma project is very much data driven. You have to be certified Six Sigma green belt at least to run a green belt Six Sigma project. And you must be aware of a good number of statistical tools and technique in order to conduct a Six Sigma project in industry or in your respective companies. When you talk about agile is something where the end result is very high level known, but you actually do the investigation and set your targets at each phases. But in Six Sigma, it is waterfall. Basically here, you know the end result that you want to achieve and you actually work towards achieving it through the statistical methodologies. That's the difference between agile and Six Sigma. Then comes another one, difficulty very high and impact is also very high projects. These are DFSS Six Sigma project. So DFSS projects where basically you do new product introduction, NPI, or new process introduction, where you want to basically develop a new process and you want to ensure that in the process or the product that you are trying to create, the quality is of Six Sigma level. So rather than fixing the defects later on trying to achieve the Six Sigma, a typical DFSS project designs the process or product in a way that you achieve the Six Sigma level of quality by the design itself. So basically, when you are doing a R&D stuff, it is DFSS. And when you are improving your current process, it is DMAIC. Any questions so far on the different methodologies? Let us move forward. Six Sigma or Sigma traditionally in the industry is seen in the two terms. The number one term is Sigma as a statistical measurement. Basically, those who has run the statistics a little bit during their high school would know there is a term called standard deviation. So inverse of a square root of standard deviation is called sigma. It is a measurement scale upon which improvement can be gauged. And basically, we measure the variance in the processes through Six Sigma or the Sigma methodology. So as a statistical scale, the Sigma is a variation measurement scale upon which improvements can be gauged. Then comes to Six Sigma as a overall methodology that drives the business improvement through a project management techniques. And this, where I was talking about, involves the DMAIC. So you will heard the word Sigma in two different aspects in industry. Sigma as a statistical measure and Sigma as the project management methodology. So do not confuse between these two. Everyone may be aware of Sigma as a statistical method because it is typically taught in the school also. But Six Sigma as a DMAIC methodology is somebody who has actually done the Six Sigma courses and they are aware that how a project is run through the Six Sigma methodology. So now we will see one interesting point. What is the difference between a traditional approach to project management and what is a statistical project management approach, and what is the difference between these two? So basically, a traditional approach of project management follows the path that there is a practical problem and you have a practical solution to this. And I will take a layman's language example. You are having a fever someday and you have taken paracetamol. Probably the day or day after. If you keep on taking paracetamol for a day or two, your fever will go away. You will not need any doctor intervention. You will not need any additional method. So this is a practical problem and practical solution. And typically what happens in the traditional approach, it does not guarantee you that the fever will not come again. You are at the God's mercy and you are at the nature to understand that this problem will be solved after this particular traditional approach. But then comes a statistical problem solving method. So what happens if you have the fever for more than 2 or 3 days, you go to the doctor. What they do is they ask you some question. For example, for how long the fever is there, for how much medicines you have taken so far. And then if they say that there is a trend in the problem rather than a one-time problem, they will go for the pathological test. They will ask you for a blood test. What they are going to do is basically converting their practical problem into statistical problem, because pathological test will tell you that your ESRR is high, you have infection, and if there is infection, which kind of bacteria is there in your body. So now what is happening? You have converted the practical problem into statistical problem. An important thing here is now you know the root cause analysis. You know why the fever is happening again and again, right? In this traditional approach, you had the fever, you took the paracetamol, you were not aware why it was happening. But using the statistical problem solving technique, now you know that. Then the doctor, according to the identified problem in your body, gives you the medicines. If you have the significant infection, they will add the antibiotics. If you do have very high level of, infection in the body, they will give a certain amount of medicine to you based on the testing that has come out. So now what they are doing is they have identified the medicines through a statistical solution. So basically now they know this is the root cause analysis and they are giving you the medicines according to it. Then they convert into the practical solution. The number 1, take a rest. Number 2, medicine. And number 3, avoid something. What is happening? You had a practical problem, you converted into statistical problem, you converted into statistical solution, and finally you came to know about the practical solution. This is the statistical or Six Sigma approach of doing the problem solving in your organization. So what is the benefit? Can somebody tell me what is the difference between these two and what is the benefit you see of statistical problem solving? Any inputs, thoughts?
Yeah, I have a question, though, Amit. When you say practical problem solving, there's a lot of repeatability, and based on which you actually convert it into statistical data set.
Right.
When you actually go into the examples that you have given, or you go to manufacturing industry, there's quite a bit of repeatability.
Right.
Okay. However, in IT industry, if you actually see, there is no repeatability. Repeatability, the amount of code that you handle as on today, the function that you are writing, probably it's never going to be repeated again throughout the life cycle. So now I have a basic question, whether it's really in IT world, whether it is really useful, because in fact, in my own experiences, we tried to implement Six Sigma. We tried to map a lot of DMAIC things, but at the end, I mean, I have experiences of 2 projects that were run. Somehow we were not getting the results that we wanted, especially in the IT projects, I'm saying. However, services, when we implemented, yeah, it was really awesome, really good. So I'd like to know from you, since you have implemented these many projects, so the relevancy of it to IT industry, and if you can connect it to IT industry kind of examples, because the people around here are all from IT, and the majority of the times are from the products kind of. Yeah.
Right. I understand. So basically, if you see each of the problems, so how many times when you implement a new ERP system to a company, you observe that the things are not in place at the very first instance. It means the user are not finding it very interactive, the UAT is not successful, there are bugs in the system, the data migration errors.
Yeah.
It happens in the real-time world. The data migration errors, the bugs in the tools or the codes will always be there. And second example is of the same is when even your internal testings, there are certain modules, those have more bugs than the others ones. For example, you had some modules written for a code that is helping the e-commerce. And in the same software, you also have the internal accounting thing. So basically, a IT developer has developed it's a, I would say, year-long implementation of the project at the customer's end. You have developed their ERP. So there are different modules: the HR module, the IT module. There will be payroll module, and then there will be a user entry module at the front end. More about the UI. You will not see that always the number of bugs, the performance of the tool is same across the different functions. Six Sigma especially works on the two things, and let me tell you that one. Number one, defect reduction, and number two, and we will talk more about is reduction in variation. Let me give you a very good example. There is a call center of a telecom company. When you call them, you are always expecting that they will pick your call 2 to 2.5 minutes. Okay, and you have a certain experience with them. Or when you call them, you are sure that their front end executives are so trained that they will resolve your problem within the first call. That is a very good company. Now there's another company where when you call them, they may pick up your phone within 30 seconds till the 5 minute. And the chances of getting your problem fixed in the first call itself is 50-50. So there are two scenarios. In the number one scenario, even if they are not meeting your expectation, their process or their performance is stable. They will pick up it within 2 to 2.5 minutes. And most of the time they will fix you is in one call. There's another scenario where they will take between 30 seconds to say 300 seconds, and they may take 1 to 4 calls, anything between them. So they are saving your time, but they are actually referring you to someone else. You still again need to call someone else and pick it up. In these two scenarios, as a customer, what is your experience? So, yeah, please go ahead.
Wherever there is predictability is always a good experience. I mean, within the limits.
Yes, so there are two aspects. LSL, lower specification limit.
Yeah.
USL, upper specification limit. And within these two limits, there is a predictability. This is case number one. Here, there is a LSL, there is a USL, but process is unpredicted. Sometimes they are very good, sometimes they are very bad. Customer will see more the variation than the mean. This is a one-line statement about Six Sigma. It means if you are traveling through an airline, there is an airline that may do very good sometimes, and that may be very bad sometimes. There is an airline like Air India. You always know there will be late by half an hour to 1 hour for sure. You have already make up your mind that I will reach my home by 5 p.m., not by 4 p.m. You are very sure about it. So customer will always see the variation first and mean or defect the second one. So what I am trying to relate here is where I have used Six Sigma in IT is to reduce two things. Number one, the number of bugs happening in the very first instant of implementation. It means to ensure that your first implementation itself is defect free. Number two, the performance or the variation of your softwares. It is very well used, both the scenarios in e-commerce, in IT, in service industry, and I have the projects, all three of them. So probably now coming to the part, you may have some examples. I would not like to comment on it, but I would like to see it, that what was the goal statement. And we are going to talk about the goal statement in very detail in the forthcoming slides. Sometimes what happens, our goal itself is not smart goal. Six Sigma needs a smart goal. Okay, so we will come back to your topic, your point again, that why the Six Sigma may seems to be not a right approach for industry. We'll touch base on this again by the end of this session. The good thing about Six Sigma is, with respect to the traditional or agile methodology, is it is systematic. It provides a structure to the projects, and we start with the end result in mind. Wherever what I feel in agile, we don't know the end result. We know it just the 30,000 feet above level, but not the exact one. It is data-driven approach, not the feeling-driven approach. Usually what happens that we have a feel that something is not right and we try to fix it up. But in Six Sigma, unless something is proved through data in the analyze phase, we do not consider it as a significant root cause. It is focused on statistically significant root cause and solutions, not based on the feel. So we have fever and we take paracetamol. It was a feeling. If somebody comes to a doctor and say, I am not feeling good, doctor will really not be able to do something. They will just give you vitamin and send you back home. But when you have the statistical test along with you, the pathological test, those are telling something about your body, they would be able to fix it. So Six Sigma is a statistical data-driven approach. Let us do further deep dive into it. The Six Sigma DMAIC goes through the 5 phases of project management. So it in itself, as I told you, it is a project management methodology. It starts with define, it goes to measure, then we have analyze, improve, and control. It is very essential that we are aware of all these phases and the intended outcome of each of them before actually jumping into the project management through Six Sigma. In define opportunity stage, we define that what is important, what needs to be achieved, what is my goal, who is my team. In measure phase, we basically measure statistically how my process is working today, and we set up the baseline. This is my starting point. Then we move to the analyze phase. That tells us what process drivers are significant. It means that not by the assumption, but statistically, what are the drivers? Those are significant and causing the problem in your processes. Improve process is the one where we propose the solution and we also do the pilot run. And yes, somebody has written in the chat, the Mumbai Dabbawalas. Let me tell you, there are only very few industries in the world, those are able to achieve the Six Sigma level of quality. The Six Sigma tells us 3.4 defect per million opportunities. It means there are 10 lakh or 1 million ways of failing something. If you want to achieve Six Sigma, you are allowed to make maximum 3.4 defects. It is very tough to achieve. And airline industry, if you count the number of flights in a year versus worldwide, I'm talking about, versus the number of accidents, they are running at Six Sigma level. Aerospace and medical, the number of operations done by doctors in a year versus the death due to the operation itself. For example, incorrect methodology in your surgery, incorrect medicines, or incorrect procedure. Only 3 or 4 industries in the world are able to achieve or even supersede the Six Sigma level of quality. A typical process in the industry, either being in finance, in e-commerce, in IT, runs to from 4.5 to 6 Sigma, 4.5 to 5 Sigma levels. So after analyzing the opportunities and seeing that what are the root cause, we propose the solution in improve performance phase, and we do the pilot run to see, is it really making the improvement in my process? If not, we need to go back to analyze. If yes, we go to the next phase, that is called control performance phase. So let me tell you, what typically happens when you are in a project, you are driving it successfully, you hand it over to the production or the client, and you actually moved away. How many times you really see that the process performance tend to go back to the original state? Same defects, same inconsistencies, same variations. You will often see that once you cease to be the supervisor of this process that you have set up, the people, those are doing it on the day-to-day, will not always follow the standards. It will often happen that again, the system performance will start going downgrade. So it is very important part of Six Sigma to ensure that we do have guarantee of the performance, and that is called control plan. That is the deliverable of control performance. We'll talk about it more. Let us see. What are the key drivers or the key principles behind the Six Sigma? The principle of market, the customer first. So as I told you, in the IT industry, if you are really defining a new process or a new project for the customer, they want you to develop a new software, we use DFSS methodology, defined was Six Sigma methodology, keeping in mind that once you have implemented that software to the customer site, it must meet the Six Sigma level of performance. And those who are those are from the hardware side of IT, you need to ensure that your hardware doesn't fail too often. Designing such a rigid system requires the DFSS methodology. Six Sigma is a data-driven approach. So it is said that anything that is not backed up by the data is just an opinion. Okay, so let me take an example. We always teach to our children that sun rises in the east. How many of you think that it is an opinion? How many of you think it is a fact? So sun rises in the east. Is it a fact or it is an opinion?
Absolutely, it's a fact.
Mm-hmm. It is a fact. Anybody else?
Fact.
Mm-hmm. Okay. Everybody will say it is a fact, but why you think it is a fact? How do you validate that this is a fact?
Because it's happening every now and then without any miss. And it tend to happen as well.
It tend to happen every day, right?
Every
We
time.
all, right. We all know that it is not the sun that rises every day. It is the earth that revolves around the sun. So it is not a fact. It is a fact because we have been taught this for thousands of years. A Six Sigma guy like me will say it is just an opinion because you have made this opinion because of what you are seeing every day. Tomorrow a manager may come to you say that my team is always coming late to the office. Is it a fact or opinion when he says this?
Now I'm changing. It might be
This
the
can become very debatable. I know, right? Because in this case, if I have to really go in a little bit detail,
I really
there
want
are
a debate around it. Okay, I have
there,
just one line statement as a manager. You guys are always late at the work. You just need to tell me. It may be my observation. That's why I'm telling you. You are a Six Sigma person who has been asked to solve this problem and ensure that everybody comes to the office on time. Okay.
so first that kind of question has to be challenged with the counter question. Okay, define what is by late. So you
It is
say
my
that if the deviation is like 30 minutes from the start time, is it called a late, or if it is 1 hour away from the start time is called a late? So I mean, yeah, that's where the whole thing settles down, right? I mean,
right. So Hiren, I certify you Six Sigma white belt. You have started thinking in that direction.
oh my God.
See,
So
green belt is very far away for you.
no.
I certify you as a Six Sigma white belt because you are already thinking in that direction. Why I have put this point? The sun rises in the east. See, so what happens when you keep on telling something or seeing something for thousands of years, it becomes a fact because of your observation. Sometimes it is very important that you do select the right tool and methodology to measure the data. If you go to my Six Sigma class, there are 40 plus tools. Those are there to statistically validate any opinion that you have about the process. I have too many defects. The company AgileWaters, when they give the training, our students are very, they may be giving very good ratings, they may be giving very bad ratings, but don't know. I mean, I have to really see that the data. Another one, Amit is very talkative during the classes. Okay, so for few, it is very interactive class, but few, it would be very, I mean, kind of a not focusing on the content, but taking the class here and there. This kind of opinion also. Unless you really see the data for 6 months or 10 number of classes, you will not be able to actually derive any value out of it. Why I have put this point here is it is very important that you are selecting the right tools and methodologies while doing a Six Sigma project to certify that the data that you are measuring, is it correct or not? Sometimes what happens that data itself is incorrect. And I can give you a very relevant example. India's hunger index, 100 plus at the moment. We are somewhere around 126. Do you really see the hungry people around you? It is just the angle of measurement of the data. Selecting the right sample size, villages versus cities, metros versus non-metros, state X versus state Y. If you do not select the right sample of your data, you won't be able to deliver any Six Sigma project. So this all is taught during the Six Sigma Green Belt class. Six Sigma is data driven, not based on facts or opinion. And the same observation by different people may be different. You may say that this data is giving me this tendency, but somebody else may see some other 10 in the same data. And that's why we also use Pareto principle in Six Sigma methodology. We never try to fix 100% of defect or the problems. We use the 80-20 rules that tells us the 80% of the problems in a defect are due to the 20% of the problem. So we focus on fixing those vital few rather than the, do you know the concept of vital few and too many? Vital few are the significant ones, and then too many are the ones where we have the small number of defects, but so many defects. So we actually use the Pareto principle to focus on vital few. And then, as I told you, it is considered in Six Sigma that the variation is evil. We must first reduce the variation of the process. That today I'm able to write the 100 lines of code, but tomorrow I'm just writing the 20 lines, or let us take it that way. My software is doing the analysis of 1000 plus lines on a certain day. It is running very smooth. All of the data that we have input into that, it was able to represent it. But some other day, because of the network bandwidth or probably the system's occupancy, the hardware with the PCs or my servers, it is not able to deliver the reports in hours time. And that happens practically in the organizations also. I have seen many a time people waiting for report to be run on the server because there are too many reports being run on the same day, probably due to the month ends. So the variation is evil. We really need to see that the consistent performance of system, the hardwares, my software should be achieved through the Six Sigma methodology. The stability of the process is very important. As I was talking about USL and LSL, the first point to see either my data is within the control limit or it is going outside the control limit some of the time. And these are my concern. Number one, priority number one, to fix the defect, those are going outside the control limit. Then I will talk about probably improving the mean. Experiment. The Six Sigma talks about a lot of experimentation statistically as well as practically. You fix some of the things and then try, is it working fine or not? That's why I told you in the improve phase, we do the pilot run. It talks about statistics and probability. Probability is very important part of Six Sigma. All of the hypothesis testing we do, we look for the p-value. That tells us what is the probability that a defect will occur or my system will perform as anticipated and or not. It builds your confidence with the statistics. 6S or Six Sigma is a team event. It's a team sport. You really need to have the wisdom of many rather than the expertise of few. You need to take the inputs of the team, those are doing, and this is common with the lean methodology. Lean and Six Sigma both are the team sports. Sustainability for the long term, as I told you, there must be a control plan at the end of any Six Sigma project so that in the future you can really predict the predictability and stability of your process should not disturb when you are away from your project. And it teaches you the project management. There are many aspects. You are handling the team, you are working within the constraint of project management. Do anybody know the triple constraint of project management that is actually taught by PMP? Anybody? What are the triple constraint when you are actually doing a project for the client?
Cost,
Iron
schedule,
triangle.
cost and schedule.
I think people are always good in project management. Yes, cost,
schedule and time.
And scope.
and scope. Third one is scope.
Scope.
These are called the triple constraint of project management. And then we have quality, we have risk, and we also have what?
Issues.
No, quality,
Dependencies.
risk I have already taken. There's one more parameter. Customer experience. Yes, it is customer experience. Yeah, these are the 6 constraints of project management, out of which these are the 3 key constraints of project management. So basically, if you pull in one direction too much, the other direction will always have an impact. It means if you want to squeeze your time, either you will increase the risk or you will increase the cost or you will deteriorate the quality or you have to decrease the scope. You will always see that if you pull or push in one direction of these 6 constraints, the rest 5, 1 or 2 or all 5 of them will always be impacted. You will also see this in the Six Sigma project management. So when you are doing a Six Sigma green belt or black belt, it covers all the project management aspects also. So it makes you a good project manager in that terms, of course, along with the agile methodology. So let us see how the journey goes in Six Sigma, from where we start and where we end. One of the important aspects is that today the organizations have commercialized the Six Sigma trainings, and to earn the money, they have created so many belts. Those actually are confusing for the end customers or the end students, I would say. We talk about the white belts, yellow belts, and I don't know how many more belts has been introduced. But when we talk about the Motorola University, that is pioneer in Six Sigma training, there are only 3 belts available there. That is green belt, black belt, and master black belt. There is no white, yellow, or any other belt. Okay. How that the journey start? First of all, your classification of level is the knowledge level. It means at this level, you will be able to define, label, name, recall, and repeat the concepts of Six Sigma. You will understand the new material and you are starting your course. So this is basically the pre-requirement. You must know what you are going to learn. Like the today's class, 1 hour class will actually tell you that what the Six Sigma is all about. It is not going to talk about anything in the Six Sigma itself. You will just know what the Six Sigma is all about. Then when you enroll for a 40 hours class, you become the GB candidate. And let me tell you, there will be many organizations, they will just charge you money and will tell you, you are a green belt. They will just teach you for 40 hours, take an exam and certify you as a green belt. It is not valid unless you are doing a project completion under the coaching of a black belt. So if you are going for a MNC, they will ask you, what is the project you have done? Only then you will be considered as Six Sigma green belt certified. Okay. What is the GB candidate? Comprehension level. You are able to discuss, explain, locate, and recognize the Six Sigma concepts, and you well understand the Six Sigma statistics through your discussions. Once you start doing your project, apply them, the concept those you have taught, apply, employ, illustrate, operate, and practice, you will become the green belt candidate. So here you are green belt student, here you are actually a green belt candidate. So journey between certified green belt and a green belt candidate is the project. The experimentation, the implementation of Six Sigma is the difference between GB candidate and certified. Once you have done a successful project under a black belt, you will be able to analyze, appraise, compare, and differentiate between the data. You will be able to basically identify the statistic strength of your data, and you will be certified as Six Sigma green belt at this level. At least 1 green belt project you should be doing. Some companies even ask for 2, but I mean, my opinion is 1 is enough. Then comes the synthesis level. The Six Sigma black belt is altogether a different story. The green belt is a 40 hours class and the black belt is a 160 hours class. It includes many more, the statistical tests. For example, design of experiment. In itself, the design of experiment class is a 20 hours class where we look at various ways of to ensure that when you are designing something new, how to ensure the Six Sigma level. I was talking about DFSS. At this level or the synthesis level, you are able to create and design, develop, and adopt the new methodologies for the organization. Create the new combination, adapt the existing to the new one. That is a certified black belt. At this level, you must be doing 2 or 3 black belt projects. I myself has done the 3 black belt projects. My 3rd one, in fact, is going on. So, and when you have the 10+ years of experience in the industry, you have coached 50+ projects, you have thorough knowledge, and you are driving the Six Sigma effort across the organization, you becomes the master black belt. There are very few organizations those certify as you as a master black belt. You may always go for that certification, but my opinion, it is more about the experience rather than certification. Anybody having the 10+ years of experience in Six Sigma, have run through 50+ projects, have done various black belt projects, conducted the training for the people on the Six Sigma, automatically should be recognized as master black belt. This person is able to recommend the methodologies to be adopted in the organization. They develop and coach the new people, and they are able to guide, lead, develop from the superior understanding of both the Six Sigma as well as the project management. So this is the Six Sigma journey from a student to master black belt. Any questions? Let me move forward. What is required for the effective deployment of Six Sigma in industry? Number one, sponsor. It should always start from the top management. If you really want to adopt the Six Sigma methodology in your organization, you must identify some big shots of the organization. Those are sponsors. Those understand the value of Six Sigma and they are able to influence the teams across the organization as a top-down approach that this is something we must adopt in order to ensure customer experience, satisfaction, quality, and efficiency of our processes. Then comes the role of champion. This is the guy who is going to support you into your day-to-day challenges when you are doing a Six Sigma green belt or black belt project. It is very important that you must have somebody who have the influence, thorough knowledge about the process where you are going to conduct your project. And here you are sitting as a green belt or black belt. Here is typically a black belt person like me who will coach you throughout your journey. And there may be some process owners, those are separate if you are doing it on somebody else's project. We must have a financial analyst who will actually calculate the ROI of your project. There would be several team members sitting across the organization. Those will support you through this Six Sigma project. The belt is project manager and link between management and team. You are sitting at the center. This is the team and this is the management. You are sitting at the center of the overall structure. Any questions? Now, I will go into little deeper. How does the define, measure, analyze, improve, and control performance goes? What we do during the 5-day class. The day one that starts with the knowledge and introduction of defined opportunities or the define phase. Basically, any Six Sigma project that we start, we must identify, prioritize, and select the improvement opportunity. You will find there are many opportunities available within the organization where you can run the Six Sigma, but you must prioritize on 2-3 things. Number one, it should be aligned with the strategic goal of the organization. You must take a project where it is giving the input as your top sponsors overall goals and objectives. If you pick something for yourself that is easy to do, it will not get the high level of visibility and intended results for you. Probably some of the IT projects Six Sigma implementation fail because the priority was not to do it with quality. The priority was to do it within the time frame and get it delivered fastest. Unless the people really see the value of Six Sigma, your project will not be able to launch. And even if you launch, you will not be able to deliver it. So it is very important when you select the project, it should be aligned with the organization's goals. Then develop a project team charter that contains your goal statement, opportunity area, your timelines, and rest of the details. We'll talk about it. Identify the VOC on VOB, voice of customer and voice of business, and define and map the process to be improved. You must be aware how the process works today. Make a flow chart, a simple flow chart, so that you know that how the process works today, and assemble and develop your project team at this stage. So Six Sigma also talks about people management. There is a module that is called team building within the Six Sigma Green Belt class. You will learn that one also. Then we move to the second phase that is called measure performance. Here you determine what to measure. First of all, you must be knowing. If you tell, I was taking an example that probably the data is telling something to me, but when you are reading that data, it is telling something else to you. It is very important to determine what exactly to be measured. If you do not measure the right data, it may give you altogether different opinion about the process. So as a team, you must be able to identify what all parameters of the process. For example, number of defects, the number of downtime of your software or server. It may be that you are measuring the overall runtime of the process, the uptime of your systems. These all the areas you need to determine what you want to measure about your IT project. Then evaluate the measurement quality. There is a system called measurement system analysis. So it ensures that whatever data you have measured is giving the right trends. Number two, that if the same data is measured by someone else, it should give the same output. So what happens typically, if there is a 1 meter road, there is an iron bar of 1 meter. Okay, you have measured it through a particular scale, but the somebody else is also measuring it through their own scale. There may be variation. Why? Because probably you have not selected right start or end point. Probably your scales are altogether different, or probably you are measuring it from some other angle. So we need to evaluate that the measurement quality is also correct. If somebody else is measuring the same data, it is not giving the different results. And that is also called R&R, repeatability and reproducibility. This is done through the evaluate measurement quality, and then we do the descriptive statistic to see what is the current baseline and if the process is stable and capable as of today or not. These are the 4 or 5 statistical measurement that we do at the measure phase. And then you do a toll gate and you move to the next phase that is called analyze opportunity. This is very important phase because this gives the right direction to your solutions. Analyze opportunity is the area where you do the potential root cause analysis of your problem. You evaluate the data through comparative methods. There are various hypothesis testing, analysis of variation like ANOVA, chi-square test. All those statistics is applicable in analyze phase. You do the perform correlation and regression analysis here, where you see that how one parameter of the process is impacting other, and you select the significant root causes then. So what was happening in traditional approach? You are working on symptoms. What was happening in statistical approach? You were working on statistical significant root cause. I have an infection in my stomach due to a bacteria. That's why I need XYZ kind of antibiotic. Then we move to the improve performance. We sit with the team and generate solution and then prioritize them. There are different various cause and effect metrics, the solution ranking metrics that gives you the statistical methods of selecting the right solutions. Then you do the implementation, and here the project management that you have learned throughout your life works the most, because it is all about change management. You need to be a very good change manager in order to be a successful Six Sigma green belt. You pilot and evaluate the solution, and then you move to the control performance. As I was telling you, often you will see that as you move away from your project, the process will tend to go back to the original state. Same defects again. Why? Because you have not developed a good control plan. The control plan is a tool that tells you that what are the key statistical parameters you are going to measure, at what frequency, who will measure it, and what will be done if something is again going out of control. You will also confirm the financial benefit and see through the control charts that your process is now sustainable for the long term. There are many other side topics that you learn. Failure mode effect analysis, it is a very good tool in itself. It is a complete project management to do a FMEA for your processes that you learn. It talks about the ranking of RPN, that is called RPN, risk priority number of each of the defect happening in your process. You also learn about statistical process control. So general model test, there are 14 kind of control charts you learn here. Sample size determination, as I told you, when we say that India is 126 at hunger index, I see the problem in the sample size there, and source of variation studies through ANOVA. So these all are the additional statistical tools that you learn through your Six Sigma journey. Any question? I hope it is not getting too much in for an hour session, but at least I must be sharing these much of basics. Otherwise, you will not understand what the Six Sigma is all about.
No questions.
Okay. So what we will do is, let me walk you through one Six Sigma project at very high level and see that how does it happen and how we measure the results. One of the project that I did was revenue maximization and improving customer experience for a company where basically they have the quotations coming from the customer. They wanted to convert it into better revenue generations model. This is the first slide, the define phase. The activities that we do in the define phases: problem identified, data collected and analyzed to quantify the problem, brainstorming, smart goal defined, as is process mapping. So what are the deliverables? You must be having a team charter. You must be knowing the KPIV and KPOV, that is key process input and output variables, a process map, team formation, risk register and exit criteria. What we did here is, let me walk you through the project charter. So the project charter have these 6 areas. There is a business case that tells you that why you should be doing this project and what is your in scope, what is your out of scope for this particular project. Okay, then you define your goal statement, what you want to achieve, what is not right in your process. Then you talk about the opportunity statement. It is not the solution. Some people actually get confused opportunity statement with the solutions. No, you don't know the solution. You are just in define phase. Solution says, opportunity statement says that how much wide is your play field? How many number of defects? What is the overall scope? How many customers impacting? These all, and what is the revenue generation opportunities? These all are your opportunity statement. Then you define the project schedule through define, measure, analyze, improve, and control phase. And here you mention your project team. What happens next is voice of business and voice of customer case studies. Basically, you do survey with your customers and you do survey internally with your business and try to relate them with your project goal. Based on the common ground between the voice of customer and voice of business, you make your goal statement. So you must be having a goal that meets the requirement of business as well as of your customers. Risk register is something where you actually try to assess what are the current risks involved, what are their trigger and impact, and then on the scale of 1 to 10, you calculate the risk priority number. What is the potential impact if this something does not go right? What is the likelihood of that happening? And then you also plan the mitigation and contingency of it. This is altogether a very detailed project management area, the risk assessment. You make the current process flow. You make the SIPOC diagram. Again, it is a very high level process flow of the process that I was telling as KPIV and KPOVs. And you basically go with the toll gate that this is my project, and you ask your managers to approve it. Then we move to the measure phase, in which, as I told you, the first thing is to define your operational definition and your data measurement plan. Here you basically define with the help of this team is what it is not writing. Here you basically define what to measure, what is the kind of data, from where it will come, who will measure it, when it will be measured, and what will be the graphical or statistical tool through which you will actually show it. Then you move forward with the analysis of the data and show the various data trends statistically. This is the descriptive summary. We typically use the Minitab or Sigma Excel statistical tool for that. Okay. You also make the value stream mapping that is coming through the lean if required a time and motion study. You measure your current sigma level. So if you see at the start of this project, the process was as 1.7 sigma, wherever the target is to achieve the 6 sigma level of performance. The processes does not work very good. And industry generally runs between 4 to 5 sigma, not more than that. Then you move ahead with the summary of your measure phase and you move to the analyze phase. The key deliverable of analyze phase is data analysis, source of variation, problem statement, cause and effect matrix. For example, what are the key statistical root causes of your problem that you do in analyze phase? You may start as simple as a fishbone diagram, where you are actually seeing what are the key inputs. Those are contributing to the overall problem statement. Then you do a Pareto to identify the top reasons out of it. Because as I told you, you will not be fixing all the 100 reasons of the problem in the first go. You will be fixing the top 20% of the reasons. Those are contributing to the 80% of the problem. So we have applied Pareto rule. Then this is something called cause and effect matrix. This actually helps you in doing the further deep dive of the problem and finding the root causes. This is the tool called FMEA, failure mode effect analysis, in which you are actually calculating your current risk priority number. So it is said that any problem statement that have more than 100 RPN, you must be fixing it. If something is less than 100 RPN, you may ignore it. You further do the potential cause analysis and propose the solutions. If required at this stage, we also do the statistical analysis that is called hypothesis testing. ANOVA, chi-square test, two sample t-test, all those statistical testings are involved if required at this stage. And then you propose the solutions. At this stage in the analyze phase, you are just proposing the solution. You are not going to implement them. With the proposed solution, you go ahead with the exit and your analyze phase toll gate. Then we move to the improve phase of the project. In the improve phase of the project, you basically define the target completion date and the responsibility. So this is the roadmap of your solution implementation. With that, you actually go ahead and implement solution, and you have to provide the what I would call a proof that the solution has been implemented. On which date? And here are the emails. Those are, you may also show the data trends here, how the process is looking like now, what are the emails sent, and what are the improvements. You may highlight that these are the things I have improved statistically, improved that, improved that, improved that. These are all the emails between the people. And important part, before and after process map, that tells you that what is the change you have done in the process that will ensure that in long term, the something is going to be sustained. Then you also do the benefit case study, that how much new dollars you have converted, how much is the overall TAT you have improved, how much the productivity you have improved, and you go ahead and do a toll gate for improved phase. And finally, it comes the control phase. The most important deliverable of the control phase is control plan. Target value, measurement definition, method, control method, responsibility, and timeline. And then you also do the 6 Sigma improvement study. So for this, the Sigma level has improved from 1.7 to 2.2. But when you talk about yield, here it was 58% on the quality earlier. Now it is 71% of the quality. So around 13-14% of improvement. It depends that what is the target of your project. Not all of the process will require 6 Sigma. especially the sales, marketing, IT, they may work very good between 80 to 90% of the target achieved. And that makes the summary. And then you create the overall executive summary or one-page summary of where you started, what you did, what are the results, and graphical representation of them. And you go for the checkpoint of final approval from the management. That is the case study. So I hope you had the fair idea about Six Sigma. Yeah, Shima, you wanted to ask something?
Hi, Amit. Thank you for this wonderful session. I have a question. Like whenever there is an idea about a project, then how would an individual can define whether it's a lean project, a Six Sigma, or a black belt project? How we can define, I mean, the category? Yes.
That's a good question. Actually, I touched based on that before you came. So you may have some of the cases where you have the simple problem and a simple solution upfront known. They are just do it or work out. You just need to sit with the team, go and implement them. Basically, what happens that to select the right methodology, if it is a difficult Six Sigma, it is a lean, or it is a just do it project, we measure it on the scale of difficulty and complexity versus the impact. So if the solutions are known and you can go ahead and implement them, it is called low hanging fruit, just do it Kaizen ideas. You really don't need to follow any methodology for them. But if the difficulty level is low, you can do it through value stream mapping, but the impact is pretty high. It is lean Kaizen. It means it is a lean project to be done. If the difficulty is moderate and the impact is pretty high, and most importantly, the solution is not known, is unknown, it is a Six Sigma project. Because by doing the statistical testing, you will come to know about the solution in this. And then if you are defining something altogether new, you want to develop a new software, you want a new ERP implementation, you want to design a new architecture, it is DFSS, Design for Six Sigma. The difference between Six Sigma Green Belt and Black Belt is the impact and complexity. So basically the Six Sigma Black Belt, as I told you, is a 160 hours of class. It teaches many more concepts. For example, 14 type of control charts, a detailed class on design on experimentation, DOE. What happens in a Six Sigma Black Belt project is it must be having more than $100K value or new revenue generation or the impact on the processes. Whereas a typical Six Sigma Green Belt project may have up to $50,000 of impact. Second thing, the team members should be within the team or probably the person sitting next to you. The Black Belt projects are the one, those are cross-functional. You need to coordinate between IT, manufacturing, procurement, sales, various functions are involved. The complexity level is too high. Then it becomes a Six Sigma Black Belt project. So lean is something where you have the simple solution and high impact. Six Sigma is something where the difficulty and complexity level is moderate and the impact is good. And most importantly, the solution is unknown. And then we may see it case to case basis.
Okay, I understand. Thank you.
I
Yeah.
mean, how much more time it's gonna take, because we are already we have crossed the Six Sigma limit. It's 8:30 time and we are at 8:45.
Right.
Yeah.
So I am done with it actually. I am just open for the questions.
Sure. Okay.
Any more questions? So no problem. If you have any further questions, you can
Probably you can
always
also give your number if people have questions. That would help, maybe in chat.